Hello student, welcome to the channel. In today's session, we are going to discuss various forces generated during machining and how to draw a merchant circle with these forces. Now, during machining, when a cutting tool removes material from a workpiece, different type of force act on both the tool and the workpiece. These forces are important because they affect tool life, surface finish, and machining accuracy. Now, in this figure, there is a workpiece that is shown the front view of the workpiece, and a tool is moving in this direction, and this is showing the depth of cut. Now after cutting, the material is look like this, and the plane along which machining is take place, it is called shear plane. Now this is the tool, and this is the chip which is moving upward direction on the rake surface of the tool. Now this is the direction of cutting, and it is also representing the depth of cut as well as the thickness of the material before cutting, that is called T naught, uncut chip thickness in technical language. Now after that, its thickness is increased, that is denoted by TC, that is called chip thickness after cutting. So we already discussed that the thickness of chip is increased after cutting because uh, due to thermal expansion, the thickness will increase. Now this is the direction of cutting, and along the direction of cutting a force is generated that is called cutting force. And to counterbalance this, on the perpendicular direction a force is generated that is called thrust force. Now on the surface of rake surface, and this is the movement direction of chip. So due to the contact, there is a force generated that is called friction. Now the movement of chip is in upward direction, so the friction force is generating at the downward direction. Now along the shear plane angle, and to counterbalance the frictional force, a normal force is generating on the perpendicular direction of frictional force. Now on the shear plane, there is a force is generating that is called shear force, and to counterbalance this shear force, a in perpendicular direction, a normal shear force is generated. Now if you look upon the look upon the on the all the forces, it is shown that the each and every force is counterbalanced by some other force. Now if you look upon the friction force, it is countered by the normal shear force, and the shear force is countered by the normal force. So this creates the equilibrium condition, and this is very important to in the machining. If all the forces are not under equilibrium condition, it is not possible to cut the material or stop the vibration. Now, now the question is coming arise, how we can calculate these forces. So a merchant circle, that is named on the merchant scientist, he's developed a method to represent all forces, and with this merchant circle we can able to find out the forces value by the derivation. So how to draw a merchant circle, we can going to learn. First you have to draw a circle, then you have to post one tool. Now this is the rack surface, and we know that along the rack surface frictional force is generated on the downward direction. So we can calculate the friction force at the downward direction. Now this is representing the representing the friction force. Now to counterbalance friction force, we know the normal force is generated. Now we can know the in this direction cutting is happening. So along this direction cutting force is generating, that is denoted by FC, and this is the shear plane. So along the shear plane, shear force is generating. Now to counter violence the friction force, a normal force is generating along the perpendicular direction, and this is the normal force. Now there is a resultant force generated by the uh, frictional force and normal force. Now join this line and this will provide the resultant one. Now we already discussed that to counter violence the friction force, a force is generated that is called thrust force. Now when we summarize the cutting force and thrust force, another resultant will generated that is denoted by R2. Now to counter violence the friction force along the perpendicular direction on normal due to shear will generated, and when we do the on the now all the forces are meeting in same point. Now we can draw the resultant of shear force and shear normal, and a third resultant comes that is called R3. Now, when we draw a perpendicular from the tip of the tool and the angle between the these is called rake angle, that is denoted by alpha. And there is one more angle generated in the merchant circle that is called beta. It is called friction angle. Now and this is also we know that the shear plane angle. Now solving this, we can find a three important merchant circle angle that is called rack angle, shear angle, and friction angle. So the process to draw a merchant circle diagram, first you have to draw a circle, then you have to draw the tool. Along the rack surface, you have to draw the downward direction friction force. Then along the cutting direction, you have to draw a perpendicular on the tip that is denoted cutting force. On the shear plane, there is a force generated that is called shear force. Now, all the forces to counter violence, a perpendicular force is generated. Then you have to draw the normal force due to friction, connect normal force and friction force, that is provided the resultant one. Then you have to draw the thrust force that is perpendicular on the cutting force. Then you have to meet the thrust force and cutting force. You have got the resultant two. Then on the perpendicular direction, on the shear force, you have draw the normal force. Then by meeting the shear force and normal due to shear, we got the resultant third. In this way, we can able to draw the merchant circle. Thank you. Found this lecture helpful. Don't forget to like the video, share with your friend, subscribe to the channel for more such videos. Thank you.